Here's a pattern. In 2016, Elon Musk said SpaceX would send an uncrewed mission to Mars by 2018. That didn't happen. In 2020, he said he was highly confident humans would land on Mars by 2026. That didn't happen either. In March 2025, he said Starship would fly to Mars by the end of that year. In January of the same year, he wrote on X, quote, 1. 14 months later, February 9, 2026, Musk announced that SpaceX is now building a, quote, 2. Achievable, he said, in less than 10 years. Mars pushed to 5 to 7 years out. The destination changed, the confidence level stayed the same, and there's a framework for evaluating what that means, one that works not just for this announcement, but for any promise that comes with a deadline and no public engineering review. 3 layers. Layer 1, the physics. Layer 2, the timeline. Layer 3, the incentives. The physics of a permanent lunar base is real, not speculative. We know how to land on the moon. Apollo proved it 6 times. We know the surface conditions, roughly 120 degrees Celsius in direct sunlight, minus 130 in shadow, 1/6 Earth gravity, no atmosphere, and regolith that's abrasive enough to wear through spacesuit seals. These are engineering problems, not physics problems. The distinction matters. Physics problems mean the laws of nature won't allow it. Engineering problems mean they will, if enough sub-problems get solved in the right order. The sub-problems are substantial. Radiation shielding. The lunar surface has no magnetic field and no atmosphere, so every cosmic ray and solar particle event arrives at full intensity. A permanent habitat needs thick regolith cover, water shielding, or underground construction. Power. Solar arrays work, but lunar night lasts about 14 Earth days at most locations. That means either massive battery storage, a nuclear reactor, or a base positioned at a permanently lit crater rim near the poles. Life support, a closed-loop system that recycles air, water, and waste for months without resupply. The ISS has been refining this for 25 years and still relies on regular cargo deliveries. And then ISRU, in situ resource utilization. The idea of extracting water from ice in permanently shadowed craters, processing it into drinking water, breathable oxygen, and rocket fuel. It's been tested in simulated environments on Earth. On the actual moon, in craters where temperatures drop below minus 230 Celsius, with equipment that has to survive dust infiltrating every mechanism, nobody has tried it yet. Each of these sub-problems is solvable in isolation, but a lunar base requires solving all of them simultaneously, in a single, integrated system, with no option to send a repair crew when something breaks. The ISS took over a decade to assemble in low Earth orbit, with the space shuttle making delivery runs. The moon is 3 days away. Every failed component is a 3-day problem at best, and a mission-ending problem at worst. The gap between a lab demo and a working system on the moon, with no repair crew and no margin, that gap has ended programs before. There's also the construction problem. A city requires structures. Either all building material comes from Earth at a cost of roughly $50,000 per kilogram to the lunar surface, or it gets fabricated from local regolith, sintering, 3D printing, techniques that exist as concepts but not as tested hardware. HALE assumed the cost figure was outdated and went looking for a better one. The better one was worse. Current estimates for Starship to lunar surface delivery run higher than the number SpaceX quotes for LEO, and the refueling logistics add complexity that nobody has demonstrated end-to-end. So the physics allows it. The engineering is possible. The question is, how fast? Layer 2. Musk says less than 10 years. The history here is documented. He said Mars cargo by 2022, humans on Mars by 2026, uncrewed Mars Starship by end of 2025. In each case, the actual delivery came years later than promised, or hasn't come at all. The pattern isn't random. The public timeline consistently runs 2 to 4 years ahead of reality. This isn't a character flaw. SpaceX builds real hardware and achieves real milestones. Starship is the largest rocket ever constructed. The booster catch was genuine engineering. The reusability program is further along than anything NASA has attempted. But SpaceX's public timelines are marketing instruments, as much as they are engineering targets. Recognizing that distinction is not cynicism, it's pattern recognition. When Musk says quote, for a lunar city, the pattern suggests 12 to 15. When SpaceX targets March 2027 for an uncrewed lunar landing, the pattern suggests 2028 or 2029. And Starship, the vehicle everything depends on, has not reached orbit as of early 2026. 9 test flights. Multiple ended in explosions. The most recent tests demonstrated booster return and partial mission profiles, but the full end-to-end sequence, launch, orbital insertion, payload deployment, controlled re-entry, landing, hasn't been demonstrated. Each test teaches something.
That's genuine. SpaceX's iterative method, build, fly, explode, learn, rebuild, has a track record of eventually producing working hardware. Falcon 9 went through its own painful arc and became the most reliable commercial rocket in the world. But Starship is more ambitious by an order of magnitude, and each iteration takes months, not weeks. The lunar variant, Starship HLS, the version NASA needs for Artemis 3, is further behind still. It requires in-space propellant transfer from tanker flights, which hasn't been demonstrated at scale. In October 2025, the acting NASA administrator warned publicly that SpaceX was not on track and threatened to open the Artemis 3 contract to Blue Origin. This doesn't mean Starship won't work. It probably will. But quote 5 and quote 6 are not the same sentence, and the gap between those two phrases is where the marketing lives. Layer 3. Why now? The official reason. The moon is closer, iteration is faster, civilization's backup needs to happen sooner. That's logical, but it's not everything. In early February 2026, days before the moon announcement, SpaceX acquired Musk's AI company, xAI. Combined valuation, roughly $1.25 trillion. SpaceX is reportedly preparing for what could be the largest IPO in history, and the internal memo that preceded the announcement mentioned lunar manufacturing of AI satellites, orbital data centers, and quote, 7A lunar city is a better story for investors than a Mars colony that keeps slipping. It's closer, more tangible, has NASA contracts attached, and comes with a timeline that sounds achievable. Less than 10 years, fits within institutional planning horizons. Mars by 2030, becoming Mars by 2035 is a hard sell at IPO. Moon by 2036 is an easier one. There's also geopolitics. China has committed to landing astronauts on the moon before 2030. Their Long March 10 rocket and Mengzhou spacecraft are in active development, and Chinese space officials have so far met their stated timelines more consistently than their American counterparts. The US, by contrast, hasn't landed anyone on the moon since 1972. Artemis 2, the crewed flyby, no landing, was still unflown as of early 2026. Artemis 3, the landing mission that depends on Starship HLS, has slipped to 2028 at the earliest, and some analysts expect further delays. With Jared Isaacman, a SpaceX ally who twice flew on SpaceX capsules, now leading NASA as administrator, the alignment between SpaceX's commercial ambitions and the agency's program is closer than it's ever been. Having SpaceX pivot to the moon brings resources, speed, and public attention to a geopolitical race that the US is not currently winning. That context matters when you evaluate why this announcement happened in February 2026 and not a year earlier or later. Does this mean the lunar city is just marketing? No. The physics works. SpaceX builds what it says it will build, eventually. But the when and the why now are shaped by incentives that have nothing to do with engineering readiness and everything to do with capital markets, geopolitical pressure, and the internal logic of a trillion-dollar company preparing to go public. And if those incentives aren't factored in when evaluating the promise, the headline gets read without the balance sheet, the framework. It works for this announcement and for anything else with a deadline and a stage. Does the physics allow it? For a lunar base? Yes. The laws of nature are not the obstacle. Does the timeline match precedent?
For less than 10 years? Probably not. SpaceX's own history suggests 12 to 15, which is still remarkable, but it's not the number being advertised. What incentives are shaping the announcement? IPO timing, competition with China, XAI integration, Artemis contracts, and a $1 trillion valuation that needs a story to sustain it. The lunar city will probably happen. Not because Musk promised it. Promises are the weakest form of evidence in aerospace. It will happen because the physics works, the economics are aligning, and multiple actors are converging on the same destination. The timeline will slip, the scope will shrink. The first city will be a pressurized module the size of a school bus. And that will still be worth celebrating if anyone remembers to call it what it is, instead of what it was promised to be. There's a problem that no amount of engineering solves, though, and it applies to the Moon, to Mars, and to every mission longer than a few weeks. What happens to a person when the nearest help is days away instead of minutes? When there's no abort, no emergency return, no quick fix? NASA has data on this, quiet data, collected over decades on the ISS and in isolation experiments. The data says the first thing that breaks on a long-duration mission isn't the hardware. It's something harder to fix, and it's something that almost never makes it into a press conference.